The Centre of Doctoral Training in Carbon Capture and Storage and Cleaner Fossil Energy is the UK Centre for Doctoral Training in the field. We cover the whole spectrum in terms of disciplines: chemistry, physics, maths, chemical engineering, mechanical engineering, materials. All these disciplines come to bear across the whole spectrum of fossil energy, including conventional power generation, including transport, and of course including carbon capture and storage. In the UK, the traditional PhD has just involved 3 years of research. Our students are still doing 3 years of research, but on top of that, they're really doing 1 year's training. The training program really covers the economic, policy and societal aspects of their research they are doing. The only sustainable future for fossil energy is for every tonne of carbon dioxide we put into the atmosphere, we have to remove a tonne of CO2 to keep the overall carbon in balance. We've got a number of projects on CO2 storage, particularly looking at the permanency of storage, and particular, will bacterial action have any impact on the storage behaviour.
My area of research is looking at the impurities within carbon capture and storage streams. So when the carbon dioxide is caught, sometimes it contains different levels of impurities. And I specifically look at the level of oxygen and its effect on storage sites geomicrobiology. When you pump different gases down there, you change how the microbes work, and that can cause problems such as hydrogen sulfide, which can corrode pipes or block injection wells. The current level of oxygen is set between 10 ppm and 1000 ppm. 10 ppm to 1000 ppm on a chemistry or an engineering scale doesn't make too much difference because you've got the atmospheric oxygen. But on a microbiological scale, even the small differences in oxygen can make a large difference overall. So I think the centre is very good at bringing people together from different backgrounds. So myself might have a background in microbiology, but also everyone else does chemistry, engineering, maths, physics. And that way you get different perspective on a similar topic. Someone with a chemistry background might have a better idea of what's happening geochemically, whereas I concentrate more on the bacteria and see how they would react in that situation. If it were to go on to inform industry, it would be a great achievement, and hopefully that will encourage cleaner fossil energy for the future.
One way of reducing CO2 is with biomass, and one of my students is working on the beneficial effects you can get from biomass in terms of reducing NOx emissions from coal and improving its combustion performance.
A large part of the developing and developed world relies heavily on coal for its energy and heating purposes, and by improving the efficiency even slightly, we can save millions of tons of CO2 from being pumped out into the atmosphere. This kind of research that we're doing here can really be reflected into the biofuel refinery industry, looking into utilisation of biofuels with regular fuels and the other effects that you get, because there are these synergistic effects which can give you unexpected results. We've used a range of biomass fuels, from very coal-like through to very, very sort of woody biomass. And this has allowed us to really try and understand the different phases of combustion and how the different fuels affect the different phases. The benefits range from having extra gaseous molecules produced early on in the combustion cycle, through to using different biomass-related products which can cause you to have a much cleaner, better burnout of your fuel. A lot of the things we focus upon are business-related, making us really sort of relevant to the problems going on and being faced in industry.
One of the projects we've got with diesel deposits in injector systems is using the most advanced analytical methods available to understand their formation.
In the last 10 years, we've seen a problem with deposits forming on the diesel injectors. And this is because of the introduction of biodiesel and octosulfur diesel that we've seen a change. The engines aren't running as efficiently as they could. There's obviously jamming, engine life is a lot shorter, and the fuel consumption is increasing. So if we can reduce these deposits, then we can reduce emissions. For the automotive industry, they want to understand what's in the deposit so that they can redesign additives to be able to prevent that. I'm collaborating with Innospec, who are a fuel additives company, and having the industrial support helps have a focus on your work. It's great to be able to see where your research will fit in and how it's applicable to the public and general life.
Diesel engines are almost a necessary evil because they help us with fuel economy, and they also help to reduce carbon dioxide emissions. But then the accompaniment to that is that you have NOx and soot. So my work is to try to improve the treatment of these emission units from diesel engines. What we're trying to do is to integrate the unit that does the removal of soot and NOx into a single combined unit. So I am an industrial sponsor, specialists in NOx treatment and exhaust systems. So that gives me guidance and getting my work straight into the market. I first worked in the industry for about 9 to 10 years before coming to do a PhD. So it is quite good for me that my PhD is as close to the industry as possible rather than a regular PhD. So it sort of keeps me one leg into industry so that I can go back in there and work.
We are producing 100 PhDs. Each project does have an industrial partner, so we're always looking to work with new partners across the transport, power generation and oil and gas sectors. The legacy of the centre will be our graduating doctoral students. They will act as ambassadors and really become the next generation of research leaders and innovators.